Okay, we've talked about a few of these. We did 30, 60, 90 the other day, where we tried to find the exact value of certain trig functions. And we're going to see some 45, 45, 90s here. And the first thing that I'll tell you is, remember that when we do these triangles here, this is A, and A radical 2, okay? And those are the expressions that we have used when we did that, okay? And we have those triangles that we made. You can put whatever number you want in here for A. But when we did the 30, 60, 90 the other day, I said that 1 was probably the quickest and easiest one to put in there, because then, you know, it makes it a little bit easier, less numbers to deal with. Same thing here. If I said that A is 1, both of these are the same, because we know this is a 45, 45, 90. So this here would just be 1 radical 2, which we don't need to put the 1 in front. So it's just radical 2, okay? If I said, let's find the sine of 45 and the cosine of 45 here. Let's start with the sine, okay? And we also know this angle up here is 45, so in this case it really doesn't matter which angle you go to because they're the same. But if I go from a 45-degree angle, so first of all, from the 45 degree that I have, when I do sine, I want you to get in the habit of writing this down whenever we do trig, okay? Just so you know how to spell it, you know how to use it. That's going to be really, really important as we continue on through trig, which we're going to be doing for the next couple of days. Sine is opposite over hypotenuse. So we're going to do O and H. So what side would be opposite of 45? Well, these are both 1. So this would be my opposite side, and then this would be my hypotenuse. So when we write the ratio here, we're going to say 1 over radical 2. But we can't leave our answer like that. Okay, so if we want to put our answer in simplest form, what do we have to do to get rid of the radical off the bottom? We've got to multiply by that radical 2. So we get radical 2 over 2. Can I simplify the 2's here? No, because this one's under the radical and this one's not. Okay, so that is my simplified form of that answer. Okay, radical 2 over 2. Now here's what I want to show you. The other thing it's asking me to do is round your decimal to 4 decimal places. Okay, there's 2 things that you can do here. First of all, type in the sine of 45 into your calculator. Just hit sine 45. It should give you a decimal. If we round to the 4th decimal place, it should be 0.7071. Okay? If I take the square root of 2 and divide it by 2, that's going to give me the same decimal. If you want to put that into your calculator and kind of verify it, that's how you kind of see if these two are really equivalent to one another. The sine of 45 is the radical 2 over 2, which is the same as 0.7071. Okay? Those are all equivalent to one another. It's kind of like when we could write 1/2 as a decimal. We could write it as a fraction. We could write it as a percent. Kind of the same idea, except here we're writing it in simplest radical form as a trig function and then as a decimal. Okay, if I did the cosine of 45, guess what? It's still 1 over radical 2, because this is my adjacent side, and my opposite and adjacent are the same thing. They're both 1. And so all of these are going to be the same. We don't really have any work that needs to be done here, because the cosine of 45 and the sine of 45 will be the same thing. Okay, so that's on a 45, 45, 90 triangle.
Wait, how do you find simplest form? Because one of the big ideas questions is, like, it's almost exactly example 5, because it's find the simplest form of 30 degrees, and I couldn't figure out how to do that.
Okay, I'll show you here in just a second, okay? Because it'll be the same basic triangle that we got here, okay? So on this one, we're going to find the sine of 30, the cosine of 30, and let's go ahead, and I think the one you're talking about is the tangent of 30. Let's talk about what the tangent of 30 would be as well, okay? So from the 30-degree angle, 1 is opposite, radical 3 is the adjacent, and 2 is my hypotenuse. As we said yesterday, the first thing that we're always going to do is we're going to label the three sides, and we always label them in relationship to the 30-degree angle, or the angle that we have. It's always the acute angle, not the 90-degree angle, okay? So 30 is the only acute angle. I mean, we know that this one up here is 60, but we're just going to use the one here because we're using 30-degree angles as our angle of reference. Okay, so the sine of 30 is pretty easy, okay? Once again, SOHCAHTOA. Sine is opposite over hypotenuse. So from 30, the opposite is 1, the hypotenuse is 2. That one's pretty simple, 1 over 2. Okay, 1/2. We should hopefully know the decimal for 1/2 without putting it into our calculator. 0.5 if you have to go out to 4 decimal places. Some people showed me yesterday that you don't have to go out to 4 decimal places, but just to be safe, that's what it would look like if you had to. Okay, the cosine of 30. Cosine is adjacent over hypotenuse. Okay, adjacent is radical 3. The hypotenuse is 2. So this would be radical 3 over 2. Do I need to do anything to simplify this? Is it okay to have radical on top? Yeah, we can't have it on bottom, okay? We can't have it down here, but I can have it on top. This is already simplified. Radical 3 over 2. To get my decimal here, you really have two options. I can either type the cosine of 30. That's probably the easy option. Just type cosine 30 in your calculator. Or you could hit radical 3 over 2, or you could do both of them and check to make sure that they're the same thing. So that would give me that as a decimal. Okay, if I had to do the tangent, just so we do all three trig functions here, tangent is opposite over adjacent. So we would do 1 over radical 3. And your homework assignment on Wednesday had one like this, okay? And so to get the radical off the bottom, what are we going to do? Yep, multiply by radical 3. And so we would get radical 3 over 3. And we can't simplify the 3, so that would be your simplest form. Okay. And once again, to get the decimal, I can either type the tangent of 30 in my calculator, and that'll give me a decimal, or I can do radical 3 over 3. They both should be the same thing. So what is the tangent of 30? What's that give me as a decimal?
5773 or 4, I mean, if you round up.
Okay. 0.577 or 4. Okay. Okay, so that would be all three. I know it didn't ask me for tan, but I'm going to go ahead and throw tan in there because we're going to continue to see all three trig functions being used. Okay? Pay attention to the directions. This one's asking for both. Sometimes it just asks for simplest form. Sometimes it'll ask for the decimal. And that's how we would do those. Okay. Now, let's say we did a 60 degree. Let's do the same triangle, except let's go from the 60. So this would be radical 3. This would be 1. And this would be 2. From the 60, now this would be the opposite side. This would be the adjacent side, and this is the hypotenuse. Okay, I won't do all three here. I'll just do the sine and the cosine of 60. Unless we want to do, we already did the tan of 60 on our notes a couple days ago. So we won't do that one. Okay, the sine of 60 is radical 3 over 2. Remember the rule that we talked about yesterday, the complements, 30 and 60. The cosine of 30 is the same as the sine of 60. So notice how these two answers are the same thing, because they're complements one another. So the cosine of 30 and the sine of 60 are the same thing, okay? And so using that same basic idea, the cosine of 60 is the same as the sine of 30. So the fact that I've already done this one here, then I know that those two are going to be the same answer. And so there's a couple of things we did yesterday that kind of tie those together. Can I do it by hand and do it from here? The cosine of 60 would be adjacent over hypotenuse. This is adjacent, this is hypotenuse, so it's just 1 over 2. Or you can compare those two, okay? And so remember that complementary rule that we did yesterday, and that would help you out there as well. All right, this one here gives us a picture, okay? And we're just going to do this top one, and then I'm going to do a couple from the worksheet with you. There's two different kinds of angles that we're going to talk about or hear about throughout this chapter. There's a lot of different ways that you can think about this. This angle right here is what we call the angle of elevation. It's the angle that something will take off, okay? And so I think of a plane, right? As a plane is going down the runway, as it gets ready to take off into the air, the nose is going to come up and it's going to form an angle with the runway, right? The whole plane doesn't come up off the ground all at once. The nose comes up, it makes an angle until eventually it gets up to speed, and then it'll take off. Okay, so it takes off at an angle of elevation. There's an angle that it forms with the runway, or with the ground. That's what we call the angle of elevation. Okay, we could be the same thing as, like, you're going to hear a lot of different examples of this. It could be kicking a ball at a goal or a field goal or something like that. The angle up here, if I had a plane, okay, that's coming in, the angle of depression, here's where this is going to be a little bit, you got to be careful with this. The angle of depression is the angle that this plane is going to form with the horizontal. Okay, so if it's flying along straight, and then obviously now we got to start approaching our destination, okay, then the plane is going to gradually approach that destination. It's not going to go drop, right? That wouldn't be a whole lot of fun for the people on that plane. So here's the thing you got to watch for. It is not the angle inside of the triangle. Okay, it's the angle that it forms with the horizontal. So this angle right here is the angle that we call the angle of depression. If you were to say somebody is depressed, then you might say they're down. D and D, right? Depressed is going down. Elevate is going up. What do you think would be true about these two angles, based on what we know?
They're congruent
Okay, how come?
because aren't the lines parallel, so
There you
they're
go.
transversals?
Perfect, good job. Okay, these two lines are parallel because they're a horizontal line. Okay, if the plane was continue to move straight ahead, that would be a horizontal line. Okay, the ground, the runway, whatever you want to think of it, is a horizontal, right? And so these two angles here are congruent because they are alternate interior angles. So the angle of elevation and the angle of depression are the same angle measure in a problem like this. Sometimes they will give it to you as the angle of depression. Sometimes they'll give it to you as the angle of depression. But the key is we got to put it in the right spot. What the most common mistake is, and we'll talk about this a lot of people want to put the angle of depression right in here, okay? And that's not always the case. Sometimes they may tell us what this angle is, but it's not necessarily the angle of depression. The angle of depression is formed with the horizontal as that plane is coming in for its landing. Okay, and that's a little bit different here, okay? Because this one actually gives us the picture of the skier. And it says that it forms a 21-degree angle with the horizontal, okay? So 21 degrees goes right here. Based on the way this picture is drawn, what side would the 1200 be? It's the opposite, okay? It's across from that angle, that I know. What side would X be? The hypotenuse, okay? And we don't have the horizontal distance here, but we don't need it. All I need is a side that I know and a side that I'm trying to find. Once again, here's where SOHCAHTOA comes into play. We have to figure out which trig function we're using. That's kind of the hard part to these problems. And it's not hard once you get the hang of it. Once we know how to use these 9 letters right here, I have O and H as my two sides. O and H tells me sine. So that tells me we're using the sine function. So we go sine of 21 equals opposite over hypotenuse. Take the time to write your equation out. If you take the time to write it out, you'll have a lot more success. Once I have the equation written out, now we've only talked about to solve 2 problems. We've talked about when x is on bottom, we've talked about when x is on top. If x is on bottom, what's our rule here? Yep, you're just going to flip-flop those 2. So in my calculator, we're just going to take 1200 divided by the sine of 21. It doesn't tell us what to round to here. So I would say let's just round to the nearest 10. Get like 3348.5. If you want to kind of see, does my answer make sense? Remember, the hypotenuse is always my longest side. So this should be longer than like the height of the mountain right here, because the hypotenuse is the longest of the 3 sides. Okay, on the worksheet, I'm going to do a couple of these with you, and then I'm going to assign a couple of them. All right, the first one we're going to do together is number 15. Okay, the first thing that I'll tell you is that all of these problems are going to form a right triangle. Okay, how you draw that right triangle really doesn't matter a whole lot. Like, do I put my 90-degree angle over here? Do I put it over here? It really doesn't matter. Okay, in this case, we've got a soccer ball. So we've got a ball down here on the ground. Okay, the ball is going to be kicked up into the air to the top of the goal. So here's my goal. The top of the goal is 34 feet high. Or sorry, 34 degrees is what it says. I'm sorry.
What type of soccer are you playing?
What type of soccer? Is there more than one?
If if the goal is 34 degrees, I think that's a different kind of, or 34
Feet.
feet.
Yeah, I know.
That's a different
That
kind of.
didn't even make sense, did it? That would be crazy. I should have thought about that before I put that down, right? Okay. The goal is 8 feet tall. Does that sound better? Does that sound more like the soccer we know? Okay, now here's the tricky part. We have to figure out which distance we're trying to find, okay? If it said, how far did the ball travel in the air? That would be this distance right here, okay? If it says, how far is the ball from the goal on the ground? That's what we're trying to figure out, okay? So you got to read the problem carefully. Sometimes it might be the hypotenuse, right? Sometimes it's the horizontal distance. Anytime it says the horizontal distance, it's that one that's straight across. Vertical distance is straight up and down. This might be like a wire or something sometimes. It could be a ball traveling through the air, whatever it's going to be, okay? So we're going to have an angle, we're going to have a side we know, and we're going to have a side we're trying to find. Got to draw a picture, okay? Trying to do this without a picture, probably going to be pretty difficult to do. Okay, here once again, SOHCAHTOA. Okay, so from 34, just get in the habit of identifying or labeling the two pieces that we have. This side is opposite of 34. This side is adjacent to 34. Okay, and the two sides that I'm labeling is the side that I know and the side that I'm trying to find. I don't care about the hypotenuse because we're not using the hypotenuse here. So if I do O and A is tangent. Okay, that tells us which trig function we're using. So we're going to go the tangent of 34 degrees equals opposite over adjacent. We just got to put everything in the right spot. Angle always goes with the trig function, and then we got to figure out if x goes on top or bottom. Once we have the equation set up, we should be in good shape because we've done this the last couple of days now. So we would do 8 divided by tangent of 34. And I would say for the most part, we're just going to round to the nearest tenth, and unless it says differently, I would just get in the habit of rounding to the nearest tenth. So this one, I think, is about 11.9 feet. Okay, questions on that one? Okay, we're going to do 16 together, but I'm going to do that one last. I'm going to jump down here to number 18. Number 18 is a little bit different kind of problem. Okay, here's the stands. And we got somebody that's sitting up here in the stands. Looking down at the field. Okay, now this is what we were talking about just a second ago. The angle of depression is formed with the horizontal. So I'm going to put like an imaginary horizontal line. And that's why this is dotted. It's not really part of the triangle, right? But it's an imaginary horizontal line. If I'm this person sitting up here in the stands, if I look straight ahead, that would be the horizontal. As soon as I look down at the field, now I'm looking, my eyes move down, right? And the angle that I move down is from the horizontal. Do not put it inside of the triangle. Okay, that would be the incorrect spot. We know that angle there is 46 degrees. And what we just talked about, the angle of depression, is the same as the angle of elevation. Those two will always be the same. So that's why we put 46 here and not here. And that would change your answer. This is inside of the triangle, and so that's the angle that we're going to use. spectator is sitting 35 feet above ground, up in the stands. I want to figure out the horizontal, there's that key word there. Horizontal means straight across. The horizontal distance from, like if the fan came down from the stands, how far from the mascot would they be? Okay, what would that horizontal distance away from them be? If I said, what is the direct distance from the spectator to the mascot standing down here on the field, then that would be this distance right here. This would be the direct distance, this would be the horizontal distance. So a couple of different types of wording that we might see. Okay, once again, from 46, 35 would be which side? Opposite. X would be adjacent. So we have opposite, we have adjacent. So which trig function do we got? We got tangent again, same as last time. One of the easy ways to identify tangent is if I'm not using the hypotenuse, it's always going to be tangent. Okay? Tangent's the only one that doesn't use the hypotenuse. Once again, x is on bottom, so we're going to take 35 divided by the tangent of 46 degrees. So about 33.8 feet. Okay, everybody good with the calculator? Know how to put all those in? If you need some help with that, let me know. All right, the last one we're going to do together is number 16. Okay, this one's a little bit different. Okay, as we read through it, Sarah is standing on the ground looking up at the Statue of Liberty at an angle of elevation of 61 degrees. Sarah is 5.5 feet tall and is standing 166 feet away from the base of the statue. Okay? So, this right here is the statue. Sarah is standing over here, and she's looking up at the top of the statue. Okay, now here's where it gets a little bit tricky. This one's a little bit different, and we'll see some of these. She is 5.5 feet tall. So as she looks up at the Statue of Liberty, it's going from her eyesight, right? From where her eyesight would be at. So this little piece right here would be 5.5 feet. We're trying to find the height of the whole thing. We know that she's 166 feet away from the statue, and she's going to look up at an angle of elevation of 61 degrees. Okay, so the trick here is it's not off the ground. Sarah's not going to lay down on the ground and look up at the statue, right? That'd be kind of awkward. If you got a bunch of people standing around, she might be kind of feeling a little bit weird about that, right? So she's going to look by just, she visits the Statue of Liberty, she's just going to look up at it, right? We want to approximate what the height of the Statue of Liberty would be. So here's what we're going to do. Set it up very similar, right? Now, what you're going to find out, unless, once again, I don't have the hypotenuse, so what trig function am I going to use again? Tangent, right? You just have to identify which pieces we know. So from the 61, tangent of 61 equals opposite over adjacent. The only thing different about this one as far as solving it is this time x is on top. So this time we're going to multiply by the 166 on both sides. So let's type that into our calculator. Okay, what's that give us?
305 feet.
Okay. So that should be about 299.5. And then that only gets me to her eyesight, right? Or where her eyes are at. So then we have to add another 5.5 feet in to this. So if I take 299.5 and add another 5.5 feet in, that's where. Had you already added it in?
Yeah, I think I
Okay.
already added that. I was trying to figure out where I got that number from.
Yeah. You had the right answer. It was just, yeah.
A step early.
Yeah. Okay, so we can't forget to add that height, if that's where it is. Now, if we're doing something off the ground like we did the ball on that first one, then I don't need to add something in, right? But if I, especially the eyesight problems where we're looking up at something, those are going to be something where we have to add an additional distance in. Okay, so hardest part is getting the picture drawn. And we're going to have several different examples of these. Here's the ones that I want you to do on this page. 17 on this side, the only one we didn't do on that page. You don't need to worry about the two problems at the top unless you want to do those for like extra practice or something. I'm not going to grade those. And then on the back side, we're going to do 10, 11, skip 12, and then 13 and 14. So that kind of gives you like 5 to do on your own.